Okay, thank you very much for that introduction. I'd like to start with introducing my company, PDF Tools. It's a Swiss company that was founded in 2002. We went to market with our PDF to PDFA conversion in 2007. Anyone knows around what time the PDFA1 standard was published? Approximately?
2005.
Yeah, exactly. It was 2005. So 2 years later, that's 8 years from now, we went to market with our 3-height PDF to PDFA converter. Now, in the meantime, PDF has become very well established in Switzerland. The first law that required PDFA for some communication between administration and citizens was passed as early as 2008. And you know, in Switzerland everything happens a little bit later than the rest of the world, so this can be considered early for Switzerland. Yeah. So, what are the areas of use for a PDF to PDFA converter? Actually, the areas of use go far beyond the obvious archiving use case we see here in the beginning. What I'd like to highlight here is the use case prior to signing. So we've heard a lot about Sockford in these PDF days here, and in Switzerland we also use electronic invoices more and more, and Swiss sales tax authorities require us to sign our electronic invoices such that it become equivalent to hard copy invoices. So prior to signing, of course, it makes sense to also convert files to PDFA for many reasons. For one, it's an added value to the customer because he can receive the file and archive it as is without any further modifications. And the big advantage of this, of course, it doesn't break the signature. Additionally, it's also an advantage for the signee because when he converts the file to PDFA, this removes all interactive elements. So what he sees is what he signs. Other areas of use are to achieve compliance, for example, with the regulation I mentioned before. The goals of a PDF to PDFA conversion is first and by far the most important, to preserve the visual appearance of the file and also all other information contained therein, such as extractable text or tagging, structural information, and metadata, things like that. Also, logging is very important. This allows the customer to locate and eliminate conversion problems. For example, you know, during PDF to PDFA conversion, fonts have to be embedded, so logging allows the customer to see whether or not on his system fonts are missing that would be required to be embedded. So, starting with the PDF, it seems that PDFA conversion is a very easy document conversion task because it seems that only the PDFA standard has to be considered, and as some of you might know, the PDFA standard has only around 20 pages of technical requirements, so it doesn't seem like a lot, and the task seems to be very easy. However, I claim that PDF to PDFA conversion is actually not so easy for these two reasons, main reasons. For one, the PDFA standard itself has mainly been designed with document creation in mind, and not so much document conversion. So some rules make it really hard to convert any PDF document. And the second claim I make is that understanding of the PDFA standard is actually not sufficient to implement the PDF to PDFA converter. We will see an example for these 2 points in the upcoming presentation. When building a PDF to PDFA conversion, PDF to PDFA converter, there are 2 strategies one can implement. Strategy A, I would call the document conversion strategy, that uses an intermediate format to convert documents to PDFA. One of the main advantages of this approach is that it is reusable for other document conversion tasks, and a very A very common example for this task would, for example, to be to simply print a PDF to a virtual PDF printer that then creates a PDF-A file. Another strategy would be the modification of the input strategy. The main advantage of strategy B is that the information transferred from the input to the output is not limited by some intermediate format, but limited by the capabilities of the PDF to PDF-A converter itself only. So in my opinion, strategy B is preferable, but many of the challenges of the PDF-A conversion apply to both strategies. Let me start with the first example of a conversion task. This is about converting document metadata to the PDF-A1 standard. So the PDF-A standard, PDF-A1 standard requires that all of the document information dictionary's entries that have analogous properties in predefined XMP schemas shall also be embedded in the file in XMP form with equivalent values. So it requires that if you have both XMP metadata and document information entries, they should be analogous. An example for such an entry would be the creation date. It's available in both means of document metadata. The PDF-A1 standard says that dates should be equal on a component by component basis. So the first two dates we see here are actually equal on a component by component basis, so they are fine. In the second example, we see that in the info dictionary, the time zone argument is missing. So these two entries would not be equal and would need some form of conversion. The third example is a bit less obvious, because when we compare it, at first we see that in the document information dictionary, the component for seconds is missing. However, the PDF standards knows default values for all entries except for the time zone argument. So if we see the third example and we consider default values, which are 0, and we compare it to the XMP metadata, where the seconds are 0 as well, we could say that these two values are equal. However, if default values cannot be considered, these two dates are not equal. So it's actually not quite clear what to do here. And when we go to the fourth example, this is actually an example from the PDF-A1 standard for two dates that are equal. However, if we remember that their default values for now, for both hours and minutes and seconds, we could see that the info dictionary is like a date. This is today. And the time we could fill up with the default values, then it would mean today, start of today, so midnight, with no specific time state. The XMP date, on the other hand, is very, very clear. This is just a date with no specific time zone or time. So of course this is a challenge for a PDF to PDF-A converter. What should be done with these dates, and how can such ambiguities be resolved? In essence, there are three different cases for such conversions. So for each of these entries, the value could be present in the info dictionary and not in the XMP. In my opinion, it makes sense to then, for a PDF to PDF-A converter, to then add it to the XMP metadata. If the value is not present in the info dictionary but present in the XMP, according to the PDF-A1 standard, one does not really have to do anything, because this already satisfies the requirement. However, in the interest of consistency, I would argue that it makes sense to add the value back to the info dictionary. Which leaves us with the third case, where both values are present, but they differ. What to do here? We find that most applications look at the XMP metadata and give priority to the XMP metadata. So, in our case, in my opinion, it makes sense to convert it to the document, to use the XMP value in both and in the info dictionary as well. Luckily, this conflict has been resolved in later versions of the PDFA standard in PDFA3 and PDFA2. There's a subtle but nonetheless important difference. In PDFA2 and PDFA3, it is distinguished between a conforming reader and a conforming writer. So the requirements for a conforming writers are that it should ignore the info dictionary. This makes it very clear that the X and P value actually has priority. For conforming writers, however, it is recommended to use consistent values in the info dictionary and the XMP. However, it's not required. The advantage of this is, for document creation, this is very easy. The document creator chooses all the values and it just writes consistent values in both the info dictionary and the XMP metadata. For a document converter, this avoids ambiguities because the document converter can essentially leave the values in the info dictionary and use correct values in the XMP metadata and avoid any ambiguities. Also, for example, it can avoid things like filling up default values that would make the dates obviously comparable. Yeah. So this is a very big step forward, I think, in PDFA2 and PDFA3. That makes conversion easier. Unfortunately, there are other examples where conversion became harder with PDFA2, but I'll come to that later. Now I'd like to talk a little bit now about converting fonts. For example, about the encoding entry of symbolic true type fonts. So the PDFA standard requires that all symbolic true type fonts shall not specify an encoding entry. I've written here how in PDF rendering encoding for symbolic true type fonts works. It depends on which CMAP is embedded into the font program, and depending which one is available, the character code is mapped to the glyph directly. So we see here that for rendering the font encoding is not actually used, so it might be, it seems to be a no-brainer to just remove the encoding entry. However, this is a fallacy because many text extracting applications use the encoding entry to extract to Unicode information. So if a PDF to PDFA converter simply removes the encoding entry, the text might be not extractable anymore. And the PDF to PDFA converter has to be aware of this and add it to Unicode CMAP to the font. I have a similar example. This is about the width mismatch. Specifically, the standards require that the glyph width information in the font dictionary and in the embedded font program shall be consistent. So for text rendering, it's such that the width information in the font dictionary is used and the width information in the embedded font program is not used for rendering. Therefore, it seems obvious to just adjust the width information in the embedded font program and leave everything as is and resolve the problem like this. Unfortunately, this is not possible because in PDF multiple fonts might use the same font program and they might use the same glyph but with different width for different character codes. So if we adjust the font program to match one font, it might be a width mismatch for the other and vice versa. This might also happen with a single font. For example, if a single font has two characters that use the same glyph, for example, this might happen with the dash and the EM dash characters. But these glyphs, these two character codes might use the same glyph with two different width information. So it's actually not possible to simply adjust the font program. One has to adjust the font dictionary's width entries. However, this leads to visual differences in the file because this width information is used to position the glyphs on the page. So if we change the width in the font program, we have to change all occurrences of the characters on the page and reposition them accordingly. This is a quite complex task and requires a lot of changes to the document, but unfortunately it's necessary. So let me speak a little bit about converting non-symbolic embedded TrueType fonts. So there are different requirements about non-symbolic TrueType fonts. For PDF A1, for example, the font shall specify Mac Roman encoding or Win-ANSI encoding as the value of the encoding entry in the font dictionary. These are two predefined font encodings which are frequently used for non-symbolic embedded TrueType fonts. However, it's also possible to get an encoding, a difference encoding, which is different. So for PDF A1, all fonts that use a difference encoding should be re-encoded, which is sometimes just not possible because the difference encoding might use characters that are not available in Mac Roman or Win-ANSI encoding. There's a similar problem when converting to PDF A2 and PDF A3, because while there is the difference encoding is allowed in PDF A2 and PDF A3, all the names in the differences have to be listed in the Adobe glyph list. And if we see the character encoding up here, the first two means, we see that the names are in the Adobe glyph list, but with the last, we see that any name might be used as long as it is mapped by the post table embedded in the font program. So if we have names there that are not on the Adobe glyph list, we cannot convert the file to PDF A2, at least not as a non-symbolic embedded TrueType font. Similarly, there's a problem we call missing glyph. By this I mean the character code that cannot be mapped using any of the standard mapping we see up here. This would, for example, be the case if any code was not available in the encoding, or if the name was not mapped by any of the CMAP or the post embedded in the font program. Such missing glyphs are usually just a bug in the creator program. So these missing glyphs often have no semantic value at all, and many times they can simply be removed without any loss. However, sometimes this is not possible because some of these missing glyphs have associated to Unicode information, so removing them would change the extractable text, which is, in my opinion, not acceptable. So we need a better solution for all of the problems we've seen here. And the solution we came up here is to create the type 0 font. So this fixes the missing glyph problem we've seen before, and also the non-convertible encodings we've seen before. The way we built this type 0 font is we add an encoding CMAP. This maps is a single byte encoding, then maps the byte 0 to 255 to the CMAP 0 to 255. Then we added to Unicode CMAP that contains all the Unicode information that was contained in the font before, so the text remains extractable. And the descended font, the CID font, is actually pretty easy to do because there are not many changes necessary to the font descriptor, and the encoding we've seen before we can rebuild using the CID to glyph ID map stream, and within that stream we can map any encodings that was used before. So this has many advantages, and another advantage, of course, is that there are no changes necessary to the page description, so no text showing operators have to be adjusted. And there's maximum flexibility with this approach without any loss of information, such as extractable text or glyphs that disappear, and so on and so forth. Now I'd like to come back to the missing glyph subject from before and the corner case of the PDFA2 and PDFA3 standards. So the standards say that a compliant document shall not contain a reference to the not-def glyph from any of the text showing operators, regardless of the rendering mode. So this also prohibits the use of the missing glyphs, and this is also the rationale behind this regulation, because in the standard it says, since the not-def glyph does not have any semantic value, this requirement is present to avoid any ambiguity which might result from its use. This is true for most font types. However, in my opinion, there is an exception where the rationale behind the rule seems to be a little bit weak. What I'm talking about is the CID 0 in type 0 fonts. So by convention, the CID 0 is the not-def glyph in CID fonts. However, especially with fonts that use the identity H encoding, CID 0 is often used like a regular glyph. Like any other glyph, is just the first glyph used is CID 0. So many times CID 0 cannot simply be removed because it's a regular character within the font, and it often also has valid to Unicode information. It's a CID like any else. However, in order to convert the files to PDFA2 and PDFA3, CID 0 needs to be removed. We do this by creating a new CID. So a new CID has to be introduced and with information added to the font accordingly. Then the embedded font program needs to be updated. For example, in a TrueType font, we copy the not-def glyph to a new glyph. So with TrueType fonts, 6 tables have to be updated consistently. And of course, similar means have to be implemented for compact font format fonts and OpenType fonts. Then we have to re-encode all text showing information. So wherever CID 0 is used, the new CID has to be used, and the to Unicode CMAP embedded has to be adjusted as well. In conclusion, this is a rather complicated step that does not only require some font PDF know-how, it also requires a lot of font know-how to build these embedded fonts up from ground up. And this is now an example for something that has been made more difficult, has made the conversion more difficult for PDFA2 and PDFA3. And with this case, with CID 0 in identity H encoded CID fonts, I think the argument about the avoidance of ambiguity is not very strong, because both as everything is just a regular glyph. So it's in this case. Now I'd like to talk about an entry that is the CID set entry that is used in the font descriptor of CID font. The CID set essentially tells a reader which CIDs are mapped to a valid glyph in the embedded font program. This is used by some PDF processing applications. However, the entry is optional in PDF. In PDFA1, however, the entry is required, and PDF1 says, let me see, the font descriptor dictionary shall include a CID set string identifying which CIDs are present in the embedded CID font file. this seems to be very clear, and for PDF creating applications, this is also a requirement that is very easy to implement. Because when the font program is subsetted, consistent CID set is created where all bits that are left in the font program are set to 1, and all bits for glyphs that are, or CIDs with glyphs that are removed, are set to 0. This all seems very easy. However, when converting the file, it seems a bit less obvious, because how can I see which glyphs in the font program are valid glyphs and which are subsetted? This is especially true with TrueType fonts, where subsetting is realized many times in a way that subsetting a glyph means that outlines are removed. However, with a converter sees such file, it's very difficult to distinguish between a glyph that has no outlines and a glyph that had outlines but its outlines were removed. So for a converter, it's virtually impossible to distinguish which glyphs are actually available in the vendor font program and which were removed, sometimes even partially. Luckily in PDF-A2 and PDF-A3 this problem was addressed, because in PDF-A2 and PDF-A3 the CID set stream is not required, but if it's available it has to be consistent. So for a PDF to PDF-A converter, the task became a little bit easier, because if there is any doubt about the correctness of the CID set, it can be removed. So this is this makes it a little bit easier. Also, I'd like to speak a little bit about repairing of PDF files. Now, why even speak about repair? The answer is simple, because there are two different points of view what the PDF file actually is. For developers like me, a PDF file is a file that conforms to the PDF reference. Therefore, no repair is necessary. However, for users, on the other hand, a PDF file is a file with the extension .pdf that can be opened in Acrobat. And as all of you know, Acrobat doesn't only open files that conform to the PDF standard, it also has some very extensive repair functionality. For example, it can also open corrupted documents with missing or incorrect cross-reference information, or it can repair other things, and it doesn't only validate, it doesn't validate the files it opens. There are also other corruptions the user expects a mature PDF to PDF-A converter to repair. For example, I'd like to highlight the repair of corrupt fonts. We've come across files that had slightly corrupt fonts. When opening these in Acrobat, the user would notice anything. The files could be viewed perfectly. However, when our customer tried to print these files, it looked very different, because the fonts were corrupt in a way that couldn't be handled by the printer. Therefore, no text appeared. And of course, such files do not meet the standards a user asks from a PDF-A file. Therefore, fonts also need to be repaired. Repairing files in a similar way as Acrobat requires a lot of experience, of course, because there's always the risk if files are repaired in a way that is different to what Acrobat does, it will result in visual differences. So one has to be very, very careful to repair the files in a similar way as Acrobat does. Therefore, a lot of experience is necessary. Yeah, there are a lot of topics not covered in this presentation. PDF to PDF-A conversion has a lot of other things that need to be done. There are many other useful features in the PDF to PDF-A converter. For example, we've heard a lot about Sogford. I'd like to, for example, it is useful in a PDF to PDFA converter if a SOC4 compliant document can be created in one step out of a regular PDF file and the invoice file. So the regular PDF has to be converted to the PDFA3 file, and the XML has to be embedded and metadata adjusted, and possibly the file also has to be signed, because as we have heard before, in Switzerland electronic invoices are required to be signed. So we're almost at the end of the presentation already. So the conclusion out of this is that, out of building the PDF to PDFA converter, is that experience with real-world files is absolutely necessary in building a PDF to PDFA converter. This is not only because the whatever works in Acrobat slide we've seen before, but it's also because the PDF standard is very powerful and allows for very complex structures. And only real-world files can reveal all the corner cases that one might not have thought of in the beginning. The problem of building a PDF to PDFA converter is actually far more complex than we thought originally. We first thought it would be done in a couple of months, but it turned to be years in the end, like with some IT projects that might happen. And also we've seen that understanding the PDFA standard alone is not really sufficient. Similarly, it's also not sufficient to just build a PDF library. One also needs to be able to repair fonts, modify fonts, or other document formats embedded in PDF, such as ICC profiles, embedded images for image formats, or XMP metadata, of course. So, actually, a pretty in-depth understanding of the PDF standard is required in order to build a PDF to PDFA converter. So I'm at the end. Any questions?
Who of you is actually doing software development similar to this? And who is not a developer and has not fallen asleep?
No one.
Is this useful? I mean, it was intentionally pretty in-depth. It was a very technical presentation. So is it good for non-developers to... Was good?
Yes.
Yeah.
To get the understanding how which kind of level we are in the problems.
The room is still full, so it's...
It justifies the decision not to become a developer.
No, it's interesting.
You have to love problems. Any questions?
Yeah. How often you're not able to convert PDF file to PDFA?
Oh, I mean, there are cases. I couldn't give a number. I don't really know.
Because in all the examples you were able to come up with some workarounds.
Yeah.
I think one problem is implementation limits usually. So
Yes.
this is because that is you should not go over a certain number, and then you need to reprocess the whole structure in order to find out whether there are solutions for that. This is, for us at least, was turned out to be sometimes a real
That's true.
showstopper.
That's true. These are problems one cannot really solve. Yes.
Yeah, tech PDF, PDF A1A, more than 8,192 entries in some place.
Yeah, or some people want to convert any PDF to PDF level A, and then we have to explain to them it's not possible. At least not with our PDF to PDFA converter.
So, out of your experience with PDF files, if you had to say or to name a percentage of problematic PDFs that especially claim to be PDFAs, or PDFs in general that have to be converted, can you name a percentage of problematic, the problematic part? I mean, is it a few examples out of a big bunch, or is it a certain amount of PDFs that cannot easily converted by PDF tools?
I don't know. I only see the examples that cannot be converted, so they come to me. And
So in other words, do you have a lot of work?
yeah, I mean, it is from time to time there's a file that cannot be converted, and sometimes it just cannot be converted. I mean, sometimes people send us file, yeah, can you repair it? And it's a file full of zeros. And there's nothing in there. So, and sometimes I can say, okay, yeah, I see this is corrupt, and maybe I can repair it, and I will try. Yeah.
And have you been active also in the conversion of non-PDF documents into document formats into PDF? So if you compare the complexity and the
yeah, we have, for example, our document converter, and it can convert Word and other formats, and it uses either it uses Save as PDF from within the Office applications, and the PDF out of there are not perfect, but they're okay, and we know of all the problems, and we can repair it with the PDF to PDFA converter, or otherwise we have to print the document and then use a virtual PDF printer, and then of course this is a PDFA unit. Yes.
Thank you.
Any other questions? Last chance? Okay, thank you very much.